This is actually a perfect lab to not have in person because it's just going over calculations and it's not anything that we're doing in the lab. Okay. Any questions for me before we start? All right. So let me just talk about how this is set up. So we'll obviously meet on Wednesdays, hopefully in person. So next week we're still online. And then the Wednesday after that is actually my birthday, and I'm taking my kids. Well, it's my son's birthday the day after too. So I'm the 9th, he's the 10th. So I'm going to be taking them, both my kids, to Great Wolf Lodge. So I don't know if that's much of a birthday present for me, but it should be fun. I've never been there. So anyway, we will skip lab, not next week, but the week after. So February 9th. Unfortunately, that's the first like real lab. And I was thinking, oh, we could do that next week instead. But then I realized that we were out. So I'll figure something else out. But speaking of that, so I kind of changed things a little bit this year. There used to be a 15% part of your lab grade for a presentation. And we did those in person. They just take a really long time to go through. And then when we were virtual, I had the students record themselves giving the presentation. But then again, that's a lot of me watching it. I don't know, like when I was in college, we never did anything like that. So I'd rather just keep it more lab based. So, and this is in the syllabus as well. So your lab grade is 30% of your total grade. So 30% of your chem grade. So if for, and I don't know, because I haven't really looked through the rosters all that closely, but if you have somebody else for lecture, then I would report to them what your lab grade is, and that goes to 30%. If you have me, then obviously I just take I take that grade and it goes into 30% of your total chemistry grade. But out of the lab grade itself, 85% I have based on the lab quizzes. So after most every lab, I should say, there's a reason we skip a lab quiz here or there. But for each lab we have, is that a chat? Someone's chatting me. My chat thing. Oh no, there we go. Okay, sorry, I keep hearing this sound. Okay. The best way to get in touch with me is just to talk. I know nobody wants to talk, but I have a hard time remembering to check the chat. So anyway, for your lab grade, 85% of the quizzes. So when we do a lab, if you look in the lab manual, and obviously you don't have a physical copy, but on Canvas, each one of the labs, I have a scanned in PDF of the lab. You should always read that lab before you come to class. But anyway, there is a pre-lab, which I base the quiz off basically for the most part. And then there's the actual lab. So the quiz will be similar to the questions on the pre-lab. So make sure you read through the lab, and you should be able to do that pre-lab just based off of the reading of that. And then what we do is in class, there's a little bit of a lecture that I have to give before the lab, and then the lab itself. And then anything you learn from that lab should help you on that quiz. But you really should be able to do the quiz almost before you even do the lab, unless I've added some questions in, because sometimes I do that are based more on the application of the lab that we do. The lowest quiz drops. So, all right, lowest drops. And that is the same, if I didn't say that during lecture, that is the same thing that I do for lecture as well. And then the 15% remaining is usually what that presentation is based off. But I'd like to try this semester to do instead that these are the completed labs and like hygiene in the lab, participation, I think I'm spelling that right. It's hard to talk and write. So participation. So basically in the lab, and I will have printouts when we actually are physically in lab, but there'll be data tables that you're filling in, or graphs that you're making, or questions that you're answering based on more like the lab. That's what you will get. That's what your 15% of your grade will be. Now I'm hoping to do it all electronically, so it just makes it easier than having to collect a physical copy. And this way, if you're absent or you forget it, it's just on there. So in Canvas, you'll see there's an assignment, and hopefully I've never done this before, and I'm not that great at Canvas. There's an assignment for, say, lab 2, for example. So you will take a picture of or type up your lab, the actual lab, not the pre-lab, and you will submit it through that Canvas link. Does that make sense? I hope that made sense. So when we have lab today, right? So, whether we're in person or not, there's going to be whatever you learn. There's a quiz that'll be due the next Wednesday at 2:59, just like we did in lecture. You have to take it by 2:59 because the answers go out at 3:00. That will be 85% of your grade, what you score on that. The lowest one drops. And then the last 15% is that you have the completed lab. Now that has to be in as well. You can hand it to me physically if you'd like, I'd accept it, but it either has to be handed in that next week. So again, there's no lab for this one. Is there? Hold on. Actually, there might be one for this lab. We don't have to do one for this lab. This lab is just calculations, but let's just pretend that we were doing one. If we had an actual lab that we were filling out with data, you would be taking a picture or typing it up and submitting it through Canvas through that assignment for lab 1, and or handing it to me that day. So if you do neither, then you just lose credit for that. So if you say like, I forgot it, like just, you have to either get it in one way or the other. So you drop the lowest drops. The lowest drops here too. So if you have a 0, so this just, this is like, say you were to miss a lab. This could be the one that you miss. So it'll drop your lowest. So if you happen to miss a lab or you forget to hand it in, this would be, you would get that one kind of get out of jail free. Okay, any questions on the grade? And then this 30% of this grade, let's say you have 100 in lab, right? Then that 30% of that will count, 30% of that will count towards your lecture grade, your overall grade for the semester. All right, no questions? Everybody's so quiet as usual. All right, so we are just going to go over some simple math stuff, so, sort of some of the stuff we talked about in lecture, and basically that's it. So I hope that you've had a chance to sign on to Google Classroom. Let me pull that up actually. And why do I have another message here? Hold on. I hate Outlook. I'm so bad at it. Unable to join the lab for some reason. Hold on one second. The host has another meeting in progress. All right, hold on one second. Did that person get in? Hold on, let me see. What was her name? Assam Hussein, are you here? Said you were not able to get in. That was the sound I heard. I'm trying to come virtually. Huh. You guys didn't have any problem getting in, right?
No, so can you hear me?
Yes, I can. Go ahead.
Okay, so that happened to me. I think you clicked on, when I tried to use the Zoom link for the chem like lab, that's what it was saying. So I went back to chem lecture and used that Zoom link and it let me in. I don't know why.
Oh, so the Zoom link is wrong. Oh, okay.
Yeah.
You're right. I didn't update it. Okay, hold on.
So he just has to use the one from lecture.
Gotcha. No, you are totally right. I did not change it. Hold on. I'm sorry. Give me 1 second. If you haven't signed into Google Classroom, take this time now to go ahead and do that. I hate Outlook. I really, really hate Outlook. You are totally right. I had the wrong syllabus up too. That was that sound that I was hearing. Okay, let me actually go in here and change that too. This is why I need a personal assistant. So in Classroom, there are, like, it'll say lab or lecture 1, excuse me, it'll be under lecture 1, but there's dimensional analysis, there's sig figs, all that stuff. I hope that's somebody who was just saying that. So let me go in here to the Zoom meeting. I think I just have to make a new link.
Is there a different like Google Classroom for lab and lecture, or it's all just the same?
It's all the same. Yep.
Okay. Okay.
Okay, how did why can't I just edit this? No, let me see, edit. Now you didn't have to enter a passcode, right? You just clicked on the link and it lets you in, right?
Yeah, you just click on the link.
Okay.
You jump in.
Oh, that is totally my fault. You know what it was is I tried to have like two different meetings, two different links back in the day, like one for lab and one for lecture. I'm like, why am I doing that? Let me just get one link that's the same. And then I did that last year or last semester. I didn't update it. Okay, hopefully that's correct. So whoever just came in, were you the ones that messaged me about not being able to get in? Let's see. Okay, Hazam, Hussein, you got in, that's good. And then who's the other person that emailed me? It was Emily Van Dyke. Did you get in too? Let me just, I'll do a quick announcement. Okay. All right. So just like class, now that I'm just making an announcement, please make sure you read. I don't know if you get like get some message on your phone or some, what is it called? A notification for the announcements. But if for some reason I have to cancel lab, I will announce it through there. And I try to send out a message to an email. Okay, so I apologize to those who did not get on. You can just go back and listen. I'll post this recording. I just talked about how the grade is calculated and just some basic stuff like that. Okay, so again, so we'll have there's a quiz. It should be live now, and you will raised hands. You guys are just gonna have to talk to me. I can't. I never look down at these things. All right, so let's start with Stephen M. What's your question?
On Canvas, for the lab section, I see the part to hand in the quiz, but is there supposed to be a part where we hand in the actual lab itself? Because I don't see a
Right.
turn in for that.
Yeah, so for this lab, there is no hand in, but for say next week's lab, there will be a hand in.
Okay, thank you.
Yeah, so just this lab will be, you'll just do the quiz and make sure you do it by next Wednesday before 2:59. But like I had said that earlier, I don't know if you, I think you were on, but yeah, when there is a lab to be handed in, like say for next week, even though next week is kind of like a bogus lab too, with like more like calculations, there are, yeah, because there's nothing to hand in. There's just a pre-lab question. So yeah, when you see the lab, like I said, I'll have printouts, but these are all in the modules. If you go through the lab, first it says it'll have like, a discussion about what we're doing, and then it'll have pre-lab questions. The pre-lab questions are what I basically base the quiz off of. And then in a normal lab, there would be another page that would be for the post lab or the actual lab where you'd fill in your data. That's what I want you to hand in. So I don't think I published it yet, but for lab 2, there'll be something like that. So hopefully that answers your question. All right, and Nicholas, what was your question?
I have a question about Google Classroom.
Go ahead.
Do we need a class code to get in there? Because when I go to Classroom to try to sign in and find it, it tells me I need a code to get in. So I wasn't sure how to like figure that out.
Yeah, it should be, where did somebody in lecture, I put it under, I think it's under the Zoom meeting, possibly, let me see. Somebody found it. No, that's not it. Somebody's told me where it was. Oh, classroom sign up. Okay, so when you go into the link for classroom sign up, let me see what this says. Oh, see, it just signs me in. Hold on.
If he clicks that link, he should be able to go straight to signing into that.
Okay, I will give you the class code, but yeah, It's weird for me on my end because obviously I'm the person who made it, so it comes up automatically. So
Okay.
class code is XV5 Z, and I don't know if that's an L. It's just like that. So it must be an L, lowercase
Okay.
L, 7H. There you go. So that's the class code.
Okay, thank you.
You're welcome. So yeah, so now that I'm in here, let me just look around. So if you go down to lecture 1. So there is no lab 1. I'll change that. I'll go in there and just do lab and lecture. But you'll see there's scientific notation and then the key, sig figs and then the key. Sig fig math, dimensional analysis, accuracy and precision, density, and then percent error and measurement. So that's all the things that we're going to talk about. Either we talked about in lecture or we're going to talk about today. Okay. Any more questions before I get started on that, and I'll come back to that. All right. Okay. So let's start with, I'm just going to go through, so let's just start with scientific notation because that's the first worksheet. So, and I'm just going to do a brief thing on it because most of the time people know this. If you don't, please ask questions. Please, like I said, read your book, tons of videos online. My old videos you could watch. But I can also answer questions too. So, all right, scientific notation. All scientific notation is a way to make really, really big numbers or really, really small numbers easier to work with. So the classic number in chemistry is Avogadro's number, which is, all right, so here I got to start counting. Okay, that's 602 sextillion. And that's how many pieces are in a mole. A mole is a unit of measurement, just like a dozen is 12. Well, a mole is 602 sextillion. And we use it constantly because we're constantly taking chunks of atoms and saying, okay, that's 1 mole. All right, that's another mole. Because just turning on your faucet for a split second, you've already let out at least 1 mole, at least 602 sextillion water molecules. So when we're dealing with chemical reactions, we're dealing with many moles of stuff. So we use this a lot to calculate back and forth between grams and all that. And we'll talk about that more when we get to that section. So rather than write out all these zeros and go cross-eyed, we write this in scientific notation. So we have this little decimal here. And the rule with scientific notation is you have to bring the decimal all the way to where there's 1 number in front of the decimal. So in this case, it would be 6.02 and then times 10 and however many times you move the decimal. And in this case, it's 23, 602, 23. Okay. This can also be written because sometimes I just feel lazy and I don't want to superscript, or sometimes like Google Forms, for example, doesn't let me. I will write 602E, which just means times 10 to the 23. That button is on your calculator. If you have one of these, which most people do, your E button is actually an EE button, and it's right above the, what is that, a comma? Right above the 7. So it's a second function, okay? So if you wanted to put this in your calculator, you would hit 6.02, right, like that. And then you would hit second to get to that blue function of the EE. Hopefully you could see that, EE. But it only spits out 1 E, that's fine. It means the same thing, 23. Okay, and then that means that number. So that's the example of a really, really big number. So let's just say we did a small number. Maybe we did 1,124, right? And obviously we probably wouldn't bother writing this number in scientific notation, but just to give you, oh, you know what, let's make a decimal point too. Let's make this 0.3. Okay, if we wanted to write this in scientific notation, the rule is there has to be 1 number and only 1 number before the decimal. So 1.1243 times 10. And how many times did we have to move it? Well, we moved it 1, 2, 3. So it would be 10 to the 3rd. If you were given just this number and you would see this, you would say, oh, okay, that's scientific notation. I have to move the decimal place 3 times to the right because this is a positive number. So I'd move this out 1, 2, 3. And as you can see, the decimal would move to there and I would be right back to my initial number. Okay. Is there anybody that's totally not familiar with scientific notation? Because again, I don't want to belabor this, but if there is a need, I will talk about it more. And please, you have to tell me because I'm not a mind reader. So those are really, really big numbers. Oh, that's a really, really big number. This one, obviously not that one. But we can do the same thing with really small numbers. So let's say we had just a decimal, right? And a lot of zeros just, again, make me go cross-eyed. So instead, and let's write 1, 2, 3. We'll write it like that. So whatever that number is. I don't want to write all those zeros. I want to make it a little bit easier to visualize. So I'm going to move the decimal so that there's one non-zero number, which would be 1.23 times 10. But in order to distinguish a number less than 1 from a number greater than 1, we have to change the exponent. So the exponent is negative now. Just think about it as you're going negative on the number line. You're moving to the left. So how many times did I move? 1, 2, 3, 4, 5, 6. So -6. And if you were given this number and you wanted to expand it back out, that negative would immediately tell you that we have to put a 0 point and then start counting 1, 2, 3, 4, 5. And then your last one would be your number 2, 3. And you can always go back and make sure that that's how many times you move the decimal. Right? So scientific notation in a number greater than 1 or a number less than 1. Okay. Any questions on that? You can type in the chat if you're too shy to talk, although I have to talk. I think everybody should have to talk. All right. I'm going to assume that's a no and we're all good. So let's talk about sig figs again. Sorry, now my dogs are barking again because the kids are home. All right, so next is sig figs. So we kind of started to talk about this on Monday. When you're talking about sig figs, any non-zero number is significant, so you don't have to worry. If it's from 1 through 9, you don't even have to question it. It's only questioning zeros. So if we have zeros after a real number, they're not significant. Or we have zeros before a real number, not significant. They are placeholders, but they're not showing accuracy. There's a whole worksheet on this with plenty of different examples, so you could go through different ones. But if there's something in your head right now that you're saying, well, what about this? Then let's go through that. So for example, I think we did, like if I do 1, 2, 3, 0, 4, 0, 0. This 0 is significant because I think about it as being protected. It's neither a trailing 0 after a real number, but without a decimal point, nor is it leading before a real number. Before a real number. So this one is significant, but these are not because they're just trailing, they're placeholders. But if I wanted to make those significant, I would put a decimal point there. Now that looks weird because in normal life, we don't see that. But that decimal point is telling the reader of this number that those zeros are not just placeholders to get that size of a number. They are actual zeros that mean something. And now I can add zeros until I'm blue in the face, and those all would be significant as well because they're occurring after a real number after the decimal point. So what I talked about on Monday is that if I take those numbers away, those zeros away, the ones after the decimal, it's still the same size number. I didn't lose the size of the number. I lost accuracy. And significant figures are all about how accurate a value is. Okay. Now, one thing to note is that when you're using scientific notation, you only include the significant digits. So if you have a number 1.00 times 10 to the third, right? Those zeros are there for a reason. Now, if you expand this, right, we're going to move the decimal place over 3 times. This number becomes 1,000. Well, how come those 2 zeros were in the number, but this last one wasn't? Well, for whatever reason, and this is a really odd example, and I can't think of where this would happen, but this 0 isn't significant, and those are. So when a number is written in scientific notation, you don't even have to question it. So you would just look at this, and as soon as you see the times 10 to the whatever digits are there, whether there's 1 or 10 or whatever, they're significant. But if you expand this number out, you would see that there is another 0, and for whatever reason, that's just a placeholder, not significant, but these 2 zeros are. You really don't come into a lot of that kind of stuff there. Okay, so sig figs, how do you guys feel about sig figs? You got to talk to me. There are tons of videos. I think I talked about this on Monday. Tyler DeWitt, like I said, he's more of like high school level kind of stuff, but you know, this is high school level stuff at this point. So he explains it in a really nice way. I think he does, and you know, he cracks stupid jokes, corny jokes, so I like that. All right, so the next thing is sig fig math, and we did talk about this. So let me pull up an example so I have some answers here too. I think we talked about this. So yes, I do remember that we talked about this. So when we add or subtract, we have one rule, and when we multiply and divide, we have another rule. So when we add or subtract, we're going to take the least number of decimal places. So let me just grab one of these off of here. Let's see. I have 125.5 kilograms plus 5268 plus 2.1. Okay, so you would get this, you're weighing three things, and for whatever reason, you have 2 decimal places of accuracy here in this measurement, but only 1 decimal place of accuracy here and here. Don't ask why, I don't know. Just an example. So 125.5 plus 5268 plus 2.1. Okay, my calculator spits out 180.28. And by the way, we're in chemistry, everything should have a unit. So don't 128, or sorry, 120.28 what? Kilograms, right? Make sure you always have a unit. You always want to put more information than you think necessary. So here I have an accuracy out to 2 decimal places, but I only had an accuracy to 1 decimal place for both of these measurements here. So I can only have to the 10th place. I can't have more accuracy than one of my less accurate measurements. So all you would do is round this up. You would just kick out that 8, the 8 would round to 2, and this would become 180.3 kilograms. Okay, so that's all you're doing, is you're looking for the least number of decimal places. Now, if you had, well, let's do the multiplication and division, and then I'll talk about multiple functions going on. Okay, so I have 0.3287. And this is a unit of grams. This is just number 1 on that sheet, 45.2. And this is grams too. Okay. So I plug this into my calculator, 3287 times 45.2. And my calculator spits out 14,85724. And by the way, my unit would be grams squared, because it's grams times grams. Treat it just as if it was an X or a Y in algebra. It would become, if this was X times X, it would be X squared. So grams squared is what happens. So when we multiply or divide, it's the least total sig figs. SF is sig figs in my world. So this value here, this is a placeholder, this is a leading 0. So this has 4 sig figs, and this has only 3 sig figs. So that means that my answer can't have, let's see how many are here, 2, 4, 6, 7. I have 7 sig figs, because my calculator doesn't know any better. It's just trying to do its job. So I can only have 3 sig figs in my answer. So that means 1, 4, and 8 stay, and the rest goes. So that 5 is going to round that 8 up. So we'll get 14.9 grams squared. Okay, so let me just do an example. I think I have one of a multiple one. Yes, number 14. Let's do this one quick together. Here, I'll try to squeeze it in on the bottom. 1250 meters minus 234, 207 meters. Oh, I think that's squared. squared divided by 5269 meters. Okay, so this is in parentheses, although we would have done it first anyway for order of operations. My main point in showing this to you is that I don't want you to take significant figures or truncate any of your answers until you get to the end. You don't want to do that in anything that you're, whether it's physics or chemistry or whatever. Take all the decimal places until your final answer. And that's when you want to look at sig figs and worry about it then. Because what happens is if every time you do an operation, you round it for sig figs, you're creating what's called a rounding error. So you're just creating that little bit of error each time. So always take all of your decimal places forward until the end and then worry about your sig fig. So 234,207 divided by 5269. Hopefully I'm putting this in right. Okay, my calculator spits out 4.444999051. And if I divide meters squared by meters, I wind up with meters. So again, this is like x squared divided by x. And I'm going to take 1250 and subtract it from that. 1250 minus second answer. Okay, my calculator, put it down here, comes up with 1,245,555,001. And this is, oh, I didn't take my meters. Meters minus meters, because the units have to match, just like x minus x would have to match too. So now you want to look at, okay, what am I doing? So the fact that I kept all of this doesn't matter because this has no decimal places and this has a bunch of decimal places. And the last function I'm doing is subtraction. So if you notice, like whether I took all these decimal places or not, it probably wouldn't have mattered because if I was just doing this one section, this has 4 sig figs and that has 6 sig figs. So I would have went with 4, 1, 2, 3, 4. So I probably would I would wind up with the same answer, but for other problems, just make sure, take all of the digits. So when I'm doing this last section, I'm subtracting. And the rule is that it's the least number of decimal places. So the fact that 1250 has no decimal places means that my answer can't have any decimal places. So that means all of these go bye-bye. And this 5 would round up that 5, and I would get 12,446 meters would be my final answer. Okay, don't mix it up and say this is 3 sig figs and I only have 3 sig figs, which is true. This is only 3 sig figs, but we're not counting sig figs when we're doing subtraction. We're counting decimal places and we don't have any. So that's what we're looking at. Okay, any questions on that part? All right. So on the quiz, there are like problems where I'm asking you how many sig figs are in a particular number. Then there's problems where what is the answer? Now, obviously, this is multiple choice. So if I was giving you this on a multiple choice, I would give you 1245.5, 1245.55, 1240, right? And drop off that 5 thinking, you know, not to be mean. Teachers aren't trying to be mean, but we can't give you multiple choice and make no other answer makes sense and you just guess on the answer. So just please read through all of the answers possible and make sure you don't make a mistake. You're looking for sig figs from this day forth in this class. So whenever it's a numerical value, make sure you're putting in the correct number of sig figs. All right. So the next worksheet I have is dimensional analysis. So let me just pull up, there's a top section where you're just converting between metric units. Well, not all metric, there's miles as well. We did some of those on Monday. We talked about moles a little while ago. I told you it was like the chemistry equivalent of a dozen. Number 9 on this one says, for a lab, you measure out 13.14 grams of calcium hydroxide. So let me write this down. So 13.14 grams of calcium hydroxide. Now, you don't know how to write this formula yet, but it doesn't even matter. The problem tells you that 1 mole of calcium hydroxide weighs 7410. Okay. And they're saying if you weigh out 13.14 grams, how many moles do you have? So right now you can just pretend like this is some made up unit that you don't understand, and that's fine. But you know that 1 mole of calcium hydroxide weighs this much. Just let's pretend you didn't know that a foot was 12 inches and you were, new to that system of measurement. If somebody just said, well, 1 foot is always equal to 12 inches and you have this many feet or you have this many inches, all you're doing is a conversion. So it could be a totally made up unit. So dimensional analysis, you always write down what you know, and this is what you base your sig figs off of. This was the measurement in the lab. The balance that they used to weigh this out only had 2 decimal places. Okay, and the problem has 4 sig figs total. So the unit that you're in, grams of calcium hydroxide, go on the bottom, and you want to end up in moles. Remember, this is your conversion factor. This is what's always true. 1 foot is 12 inches. 1 year is 365 days. 1 liter is 1,000 milliliters, whatever is true. And we know that 1 mole of calcium hydroxide weighs 7410 grams. So we take our 1314 and we divide by 7410 and we get 0.1773. And that is moles of calcium hydroxide. Full labels, please. Now, let's see. Let me just put this in 1314 divided by 7410. Yeah, so this answer was much longer. It was 0.17732793352. So you've got to be able to look at this and say, this is my accuracy measurement here. This is how accurate my answer can be. The mathematical function that I'm doing is division or multiplication. It's the same. If this number 7410 was on top, I would have been multiplying by it. I can only have 4 sig figs because this is my measurement of accuracy. So I come over here and say, okay, that's not significant. That's just a placeholder. 1, 2, 3, 4, and the rest of these go away. And the 2 doesn't do anything to the 3. And that's how we get the 1.1773. So that's dimensional analysis. And there's a bunch of other examples, and I'll let you go through it. There's ones that are a little bit longer, like the one we did on Monday. And again, there's some other ones that talk about moles and atoms, and you don't need to know how to do mole conversions yet. You just need to know what's true. Okay, the next one is accuracy and precision. We talked about that one. I think we talked enough about that one on Monday. Remember that accuracy is getting the value that you should get. So let's say I needed you to get 13.14 grams of calcium hydroxide and you got 13.12. Well, that's pretty accurate. I would call that accurate. Now, let's say you weighed that sample over and over again and you got 1312, 1314, 1315. You got all clustered around that answer. You're both accurate and precise. Okay. But if you got 15, 15, 15, you're precise, right? You're getting the same thing over and over again. That's precision, hitting the same mark over and over again, but you're not hitting where I actually need you to be, right? And then you could be neither accurate or precise. So we talked about that Monday. I'll leave it at that. All right, density. And again, please stop me if there's any questions. Density real quick, make sure you know how to work with the density formula and if the variable is in the denominator. So density is always a mass over volume. It's usually grams per milliliter. And please remember that 1 milliliter is 1 centimeter cubed. Centimeter cubed or cubic centimeter is the same as a milliliter. They're interchangeable. So this could say grams per cubic centimeter or grams per milliliter. And this could be any mass and that could be any volume, but this is what you're going to find anytime you look up density. So let's see here. Let me do a problem. So problem 1 just says, you have this many grams and you have this many milliliters. What's the density? You take mass and you divide it by volume. Easy. Okay, so let's do one where we're solving for grams. Number 2 says a solution has a density of 1.50 grams per milliliter. That's my density, right? And we also know that it says how many grams. So question mark is grams. Grams are it's my variable, my X, right? How many grams are needed to obtain 10.0 milliliters of solution? 10.0 milliliters, right? So all we're doing is solving for G. If you don't like that it's a G, make it an X. It really doesn't matter. But, and you might do math a little differently than me. I learned math before they made it all fancy. But in my mind, I just multiply both sides by 10 to get rid of it. And I wind up with 15.0, right? And now your calculator is going to spit out 15, but that's only 2 sig figs. And the function, the mathematical function that we did was multiplication. And we have 3 sig figs and 3 sig figs because that 0 is happening after a real number after the decimal, right? So I could take that away. It's still the same magnitude, it's still the same size, but that 0 shows accuracy. The same with that 0. I could take that away. So the only reason I have it is to show significance, accuracy. So your calculator would spit out 15. You need to be putting in the 0.0 to make sure your answer has 3 sig figs. And then what is the unit? Well, we canceled out milliliters, right? This was milliliters. That canceled, and we'd be left in grams. Now, what's great about a problem like this is I can go ahead and take 15 grams and divide it by 10 grams per milliliter, and I will get out grams per milliliter, and I will get out 1.5. You can always check these answers, is my point, right? Plug it back in and make sure you get the right answer. Okay, let's do one where there's volume. Okay. All right, I'm going to do 4B. So part A says the density of mercury is 13.16 grams per milliliter, 0.6 grams per milliliter. And the question is, what volume would 120,000 milligrams of mercury occupy? So 120,000 milligrams. So remember, we're looking for volume. So we're looking for this down here. So again, you can make this an X if you want. That's what we're solving for, but X in milliliters, because this is a gram per milliliter. So this is going to come out in milliliters. We have got to put this in the unit of grams. That's why units are so important. And I drive them home to write them out, because let's say you just plug that 120,000 up there. If you write milligrams, you're going to see it. But if you just write the 120 in there, you're not going to see it, and you're not going to realize that you're not in the right unit. So this has got to get changed to grams. Now, maybe some of you see this as just moving the decimal point 3 times and you get 120 grams. But if you want to do it dimensional analysis wise, milligrams go on the bottom and the grams go here. Milligrams cancel. And how many grams to how many milligrams? Well, milli is 1,000. A thousandth of a gram. So 1 gram is 1,000 milligrams. And the way I always think about it is a gram is bigger than a milligram. Milligram's really small. So there's a lot of milligrams in 1 gram. But if you go grams to kilograms, kilos, right? Kilograms are huge, much bigger. So it's 1 kilogram to 1,000 grams. So kilo is 1,000 and milligrams is 1,000th. So however you want to remember it. And like I talked about, you have the metric conversions here on the back of that periodic table that's under your classroom materials. So when you do that, you're dividing by 1,000, you're moving the decimal place in. So this is 120 grams, okay? Now notice your sig figs. This only had 2 sig figs, this only has 2 sig figs. That 0 is a trailing 0. We need it. Because if I take it away, that's 12. That's a lot different than 120, but it's holding that place. But these are the only 2 significant digits. If I wanted that 0 to be significant, I'd have to put a decimal there. All right, so let me just erase this down here. So if you haven't written it down, just write it down real quick. Can't talk. And let's do this. So this, when the variable is in the denominator, I find a lot of students have a hard time with this. So if you divide both sides by 120, let me just write this out in pink. If I divide both sides by 120, right? If I were to do that, right? It would cancel out the 120 here and I would get 13.6 divided by 120. That doesn't take the X or the milliliters out of the denominator. So what you just solved for is 1 over milliliters. So you can flip that in your calculator by doing 1 divided by the answer and it'll flip it over. But I just want you to realize that doing this does not bring the X out of the denominator. You have to flip the fraction. So another way to look at this, and I think the way a lot of you guys have learned this, is to cross multiply. So look at this as 13.6 over 1. So I'm going to cross multiply, right? I'm going to go this way. So 13.6 X is equal to 120 times 1. And then you're going to divide divide both sides by 13.6. And you would get X equal to, where's my answer? 8.8. Now there might be more decimal places. I'm not going to put this one in the calculator, but you could prove it to yourself. There might be more decimal places, but because we only have 2 sig figs here, we can only have 2 sig figs in our answer. So we have 3 in our 13.6, but this 120 brought us back down to 2. And that would be your answer. And again, take 120 and divide it by 8.8, and you better get 13.6, or else the answer that you just found was wrong. All right. Is everybody still alive? You guys are killing me.
I'm good.
Thank you. I'm gonna make you guys talk extra. I'm gonna call on you like crazy when we get in person. Okay, the last thing is percent error and measurement uncertainty. Okay, percent error. That is this is also on your periodic table. Back of the periodic table, percent error over in the top right. So what it looks like on the back of your periodic table is absolute value of, let me just write it the same way, not that it matters. Actual minus theoretical over theoretical. So what does that mean? Actual is what you got. What you got, okay, your answer, right? You went into the lab and you did something and you got a value. That's your actual. Sometimes this is also called experimental. Okay, what you found in the experiment. And then theoretical, sometimes called literature value. Kyle, can you please stop? Okay, but don't make noises. My son is outside the door. I told him that you looked at the quiz. I did, okay. That's my soon-to-be 10-year-old. And theoretical is the accepted value. Okay, so the accepted density of water is 1 gram per milliliter. You went in the lab and got 0.98, right? So that's what it would look like, okay? So your percent error, you want it as low as possible, right? You want to be as close to the theoretical value as possible. Okay, so what you're doing is you're saying the difference between what you got and what you should have got over what you should have got. And again, the closer you are to the theoretical, the smaller the numerator, and then you divide by the denominator. So hopefully you're getting this really, really small number. And then, oh, by the way, it's times 100 because it's a percent. You want the smallest percent error possible. So you want what you got and the theoretical to be as close as possible. The absolute value just makes it so that you don't wind up with a negative number. So it doesn't even matter whether you take actual minus theoretical or theoretical minus actual, as long as you just ignore the negative sign, if there's any. Some textbooks, some teachers don't use the absolute value and they want the negative. And I forget which way. I think you want to do theoretical minus actual maybe, so that if you're over the value or under the value, one's negative, one's positive. I don't know. I don't teach it that way. I just teach it as an absolute, you're this much off, not that you're over or under. So for me, it's always going to be a positive value. Okay, so let's do a problem like that. You can ignore 1A. It just says what is Susie's absolute error. Absolute error is just when you take the actual minus theoretical and you just say how far are you off, not as a percentage. Okay, but 1B says what is Susie's percent error for the lab? So if we read question 1, it says the accepted, oh, look at that. The accepted density of water. It's like I didn't even look at it. I was doing that problem. The accepted density of water is 1 gram per milliliter. In the lab, Susie calculates water's density to be 0.85. Susie should not be allowed in the lab, right? So the her percent error would be the difference between 0.85 minus 1.00. Oh, and by the way, for percentages, don't worry about sig figs for percentages. Just give me a decimal place or two. I don't worry about sig figs with percentages because there's different rules and I can only have so many rules. So actual minus theoretical over theoretical times 100. Okay, and in this case, Susie's percent error is 15%, which is pretty bad for the density of water. Like I said, that shouldn't be that hard to get because it's just weighing and measuring. Okay, so that is that. And then on this worksheet, number 3 says, is Ray's experiment accurate, precise, or neither? And you can read through the problem, but he was precise because he recorded a bunch of trials, but they were not very close. So all his trials were very clustered together, but they were the wrong number. So he was precise, but not accurate. And then there's that. Then there's some things on measurements, like looking at tape measurements or beaker measurements or graduated cylinders. Just a quick note on that, and then I'll take any questions, is when you are reading an instrument, you are always estimating the last digit. So the example here is, what do we'll just do whole numbers, 1, 2, 3. So this is some ruler with no graduations on it. So you measure and your measurement is, whatever you're measuring is that long, okay? So your certainty is just 2. You know it's 2, and then you get to estimate 1 more digit. So maybe, let's see, 2.4. That's what I said on my answer. So it's not quite half, it's maybe 2.4, and then whatever, this is in centimeters. So this is the estimated digit. Now, if I had a halfway mark, and then let's say 1, 2, 3, 4, 1, 2, 3, 4, right? Then, okay, if I had those hash marks on the ruler, I could say, okay, that is definitely 2.4, and then I can estimate that it's 2.41. Then this becomes the estimated digit, right? So on and so forth. So the more of these graduations, the more of these little tick marks that you have, the more accuracy you have, and you can estimate the last digit. And that digit is significant. It's just where your uncertainty lies. Okay. And one note, because I think this is in the reading, so make sure you do the reading on, I think it's in next week's lab, is about the precision and accuracy of certain laboratory equipment. This is a question I always ask. Beakers versus graduated cylinders. Beakers are not accurate I shouldn't say in the least. They are a rough estimate. So if you fill a beaker and there's a 50 milliliter line on it and you fill it up to that 50, that's about 50 milliliters. The people in the beaker, I always joke around and say the people in the beaker factory just close their eyes and draw lines. It's about 50. But if you want actually 50, you would use a graduated cylinder. That's what you'd want to use. And you'd want to use the smallest graduated cylinder possible. So if I wanted to measure out 45 milliliters, I would want to use a 50 milliliter graduated cylinder, not a 100, and definitely nothing larger than that. So you always want to use the smallest possible graduated cylinder. And beakers, like I said, if you know you need about 100 milliliters of some liquid, some substance, you would go get that, pour it into your beaker, say it's about 100, and bring it back. So not an accurate way to measure liquid at all, but it's just a quick and dirty way to measure that. All right. All right, hopefully that wasn't too fast. Percent error in measurement. All right, talk to me, guys. Let me take attendance while you guys are thinking about things. So I know I said this during lecture, but you have to study chemistry with pen in hand. Oh, were you guys talking to me in the chat? It wasn't even on my thing. It didn't even come up. I'm good, thanks. Yes. Oh, I have a quick question. Yes, go ahead, Candace. Sorry, I moved this off screen and it wasn't even showing it to me. Oh, it was only 4 minutes ago. Good. It was not that bad. Okay. Where'd Candace go? Go ahead. Let me make this smaller. Did we lose Candace? Candace, where'd you go? Oh,
I
here we
think
go.
she wrote something in the chat.
Yes, okay. I'm not
Rebecca.
hearing it. When you say not to use a negative, do you mean make it positive? Nope. It's just like if you were to do this and your actual, like in that last example, right? The actual was 0.85. So 0.85 minus 1 would have given you a negative number. The absolute value, you just ignore it. So you don't want to put the negative. That's all absolute value does. So you just ignore the negative sign if there was a negative sign. Okay, awesome. Oh, okay, sorry, I didn't see your mic doesn't work. All right, so let me just do the rest of this. Wish there was an easier way to see people.
I have a question about sig figs.
Yes, please, I love questions. Thank you. Let's go. Let's hear it.
I'm looking at the pre-lab and just as an example, but the numbers with scientific notation, like for example, 6.63 times 10 to the 8th, would that only have 3 sig figs still? Because all the zeros after it are just filler.
Exactly. If you write something in scientific notation, you're only showing the sig figs. So for example, if let's just say, let's expand this out. Like it was 1, 2, 0, 0, 0. If I wrote it like this, that means that for whatever reason, this 1 and this 2 weren't significant, which I'm sorry, that's a bad example. I'll leave it as zeros, but yes, you are right. Let me not say that. That gets into a confusing topic, but yes, only what's written. If these zeros were significant, but those weren't, they would be included in that. So yes, that scientific notation is the easiest one because you just look at it and whatever numbers are there and not this, right? You're not looking at the times 10 to the 8th. It's only the actual number. But yes, does that answer your question?
Yes, thank you.
Okay, so let's see. We have Joseph. Let me just get anybody else. Go away. Just go away. Go ahead.
I have another question.
Yes, go right ahead.
Okay, so on like the number behind you, the 6-3, like say you put a decimal place like after the 2 zeros that you underlined,
Yep,
would the 3 zeros after that still count?
they would be significant. Yes.
Okay, thank you.
Yeah, because why would I put them? Like I could take those away and it's still 66,300, right? So I'm putting these last 3 zeros to tell you that I know them to be 0. Yep. So that shows accuracy. My, I've been doing this for so long. I try to always find ways that are going to make it, easy for you guys to understand. So if you cover them and this number stays the same size, then they are significant. They're showing accuracy by putting them in. Does that answer your question?
Yeah, thank you.
Is Roman here? I don't see Roman. I want to make sure I don't miss you. I'm just trying to, oh no, wait, my screen's, hold on, I'm not seeing my.
Present.
You are, okay, there you are. Sorry. I need to use my other laptop when I do this. I can't look at this. Okay, what about Caleb? I don't see Caleb. Right, Caleb, you're not here. I'm gonna say no. And I saw Azam. Nicholas was here, right? Because I answered your question. Julio. I don't see Julio. I'm going to say no for Julio. Gregory, Luna. I'm going to show them on the camera what you guys look like. You guys want to see real fast what I have to deal with? This is what I'm dealing with. I need to not be home anymore. Okay, I'm going to assume Gregory's not here. Greg, last
He's
call.
here. He said it in
Oh.
the chat.
Oh, he's in the chat. Where is he on the screen? Oh, there you are, Greg. I'm so sorry. Okay, fine. All right. I think I'm just gonna do a Google form to do attendance. It's much easier. All right. I don't see Aiden, or am I just not seeing Aiden? Going once, going twice.
Here.
Daniel. What?
Can you hear me?
Oh, yes, I got you. God, I can't see. All right, Daniel. There you are. I see you. Yep, gotcha. Okay. Timothy Scott. I'm just bad. Like I shouldn't, by the end of the day, I can't see anything. I'm going to say no, Timothy. You guys help me out. And then Rabit, I don't see him either. Oh, no, maybe that's you. No, that's Roman. Okay, I just saw the R. Okay, Ava, I see. Hi, Ava. Is your hair still long, Ava?
Yes, yes, it is.
Emily, now Emily Van Dyke. I see Emily Rosillo. Is that a different Emily? Yes, that is. Okay. Okay, Emily Van Dyke going once, going twice. Okay, I'm gonna say no.
She's here. She's in the chat.
She's in the chat. Why do I not see you on my screen then?
Her name is Evan.
Oh, okay, there we go. Yes, Evand. Okay, gotcha. All right. All right, guys. Well, any questions for me? So you got to take the quiz by next Wednesday, 2:59. I would take it either now, or if you want to watch some videos or do some worksheets, but I would take it, before the weekend, while it's fresh in your mind. The best way to get in touch with me again is through Canvas. I suck. I hate the Outlook. I don't know why. I wish they would just go to Google. Canvas would be the best way to get in touch with me. I check that more regularly. You're going to be taking quizzes that are going to count towards 85% of your grade, like the one you're going to take for this lab. You get to drop the lowest one. So if you forget to take it, that's just your dropped one. When we do have an actual lab, like next week, even though it's not a real lab, there are sheets at the end called lab or post lab. You will submit those through Canvas. There'll be an assignment. So please just take photos or upload them somehow. If you can type them out also and put them in a document and put it there. Anything else that I'm forgetting? So we'll be virtual like this for next week. And hopefully we're back by then. All right, last call for questions and last call for Timothy, Rabit, Julio, and Caleb. Let me go see what's happening in the chat. The chat's not even telling me what's going on. See, I didn't even see this. I too have yelling, playing kids. Oh, that's good to know. And the chat isn't even making a noise anymore. So anyway, yes, screaming, playing kids are fun, but they just got on their iPad, so I won't hear from them then until I take them away. All right, everybody. Well, I will let you go. Have a lovely night. I will see you on Monday. I think most of you are in my class. I don't see anybody really new that I see. And we'll talk then. Good luck on the quiz. And you have a quiz for lecture too. So remember, there's those quizzes and all that good stuff.
Have a good day. Bye.
You too.
Have a
See you
good
guys.
one.
Thank you. See ya.
Enjoy your week.
Bye.